Hi, we're Team 18959, a multidisciplinary senior design team in the Kate Gleason College of Engineering working on developing a fall prevention device. We are comprised of two mechanical engineers, two biomedical engineers, one industrial engineer, and one computer engineer. We are working with lifetime assistants to create a sensor that is able to detect when an elderly patient is trying to get up out of bed. Our stakeholders are interested in a cost-effective, non-intrusive, and modular solution that will accurately determine when a patient is getting up out of bed. The key goal of this project is to create a sensor that can accurately alert healthcare staff when a resident is attempting to exit the bed, that can also fit different bed sizes at a reasonable cost. The core idea is to sense when a patient is starting to get up. Our device will send an alert to a caregiver, and they will assist the patient in getting up out of bed in a timely manner. Currently, Lifetime Assistance uses two sensors to notify when a patient is getting up out of bed, one being a motion sensor that typically overreports, and the other one being a bed pad, which tends to underreport. These two sensors are very expensive and need to be replaced often. For our solution, we came up with the MagCare strip, a modular bed pressure sensor that sits on the edge of the patient's bed. It allows for caregivers to respond quickly to help the patient before they exit the bed. This is a diagram of the electrical components of our MagCare system. We have two conductive plates on either side of the foam cavity, one towards the top of the foam block and the one at the bottom. The foam not only prevents the plates from touching before pressure is applied, but it also provides a soft material that blends with the mattress, preventing deformation and improving comfort. When a patient attempts to get out of bed, the patient's legs will put pressure on the device, which completes the circuit. Once the circuit is complete, this will then send a signal to the caregivers to provide assistance to the patient. This is a demonstration of our electronics in place. So this is for all four in a row because we only have four for now. But this is the first one, second one, third one, and then that's the fourth one. And then once Trey presses the fourth one, sends a signal over. As you can see, as any of the sensors are pressed, a signal is sent to the central monitor that Lifetime Assistance already has. This allows us to maximize effectiveness and minimize cost by incorporating our device with our existing system. This is a detailed view of our waterproofing used on the MagCare strip. We are using polyurethane coated nylon, which prevents water from seeping through. This is in case of any accidents involving liquids that may occur. This is a detailed view of our attachment method. We have fabric snaps that are attached to the cover and the polycarbonate plate. These snaps will allow for the device to be easily installed and removed for cleaning and repairs. The polycarbonate plate provides structure to the design while also allowing the MagCare strip to be modular, sitting at either one side of the bed or both. Our expected result is for our sensor to be more precise and have higher accuracy than current sensors that Lifetime Assistance has in place. In addition, we want it to be fully modular, non-intrusive, and cost-effective so that this can fit on any bed size and correctly alert staff when a patient is getting up out of bed. While the main design process has gone relatively smooth, we've met unexpected resistance in our attachment methods. We resolved this by continuously iterating through our design until we landed on the snaps, which allow for the device to be effective while meeting our client's standards. And we just want to acknowledge our advisor who has supported us through our project, Alexander Louis, as well as Lifetime Assistance, who have provided funding and guidance for us.